Yes, so here we have a question. You can see this, and in this question, a lot of chemical properties are going to be assessed. So let's see, but so what you need to solve, first of all, you just need to see that what we have actually. So this is actually the carbon and oxygen compound, which is actually carbonyl, because on both sides we have carbon, right? So this is carbonyl functional group. So it may be ketone or it may be aldehyde. So right now on both sides we have carbon, so it is ketone. So itself it is ketone. And the second functional group that we have over here is this, which is a double bond, carbon carbon double bond. So in this compounds, the chemical properties of ketone and the chemical properties of alkene can be checked, right? So let's see what are these chemical reactions, bacho. So in the first one, you can see this, that this is hydrogen and nickel catalyst, right? So we know that this is the chemical property of alkene, and this is a reduction process. So whenever you react it with hydrogen, so we know that what is going to be happen, the double bond is going to be break and the hydrogen are going to be added over there. So thus the whole structure will remain same. The only difference is the removal of double bond. You just need to remove the double bond from the structure, and this is the final product that you have. Is that right, every one of you?
Yes, sir.
And then in the second one, if you see over there, so again, what we have over here, we have actually NaBH4, which is a reducing agent, right? So this is actually a reducing agent, and we know that NaBH4 का जो effect है वो सिर्फ और सिर्फ किसके ऊपर है, कीटोन पर है, एल्डिहाइड पर है और कार्बोक्सिलिक एसिड पर है. They can go backward to form aldehyde, or they can go backward to form primary alcohol and secondary alcohol. So let's see what is going to be happen. We just have ketone right now, so ketones can go back to form secondary alcohols. So what is the chemical property over here is going to be checked. The chemical property is actually ketone का backward reaction है और ये secondary alcohol बनाएगा. You just need to draw the structure same as it is, that is over there, and the double bond is also be there. We just need to remember that over here the ketone functional group is going to be ended, and over here we need to attach OH. So this will be the secondary alcohol which is going to be formed. Is that right, every one of you? Yes, everyone, is that right?
Yes, sir.
And then in the compound
Sir,
S,
आप
जी
दोबारा
बेटे,
एक्सप्लेन कर सकते हैं आर को?
जी देख लें आप, कोई मसला नहीं है. R is what? You need to draw the same structure. We have ketone over here. So whenever you are going to reduce ketone, it is going to form back again secondary alcohol, because ketone is formed by secondary alcohol. So if you reduce this, so it will form again secondary alcohol. You just need to remove the double bond. Just need to remove the double bond over here, right? And you need to attach OH over here. We should also add H over there, but we know that the carbon connected H are not going to show in skeletal formula. That is why I'm not drawing that. Okay.
Yes, sir.
And
Sir,
then in the third one, Ji bete,
sir, only NaBH4 is used for reverse reaction for ketones.
you can even use lithium aluminum hydride as well, bete. But you need to keep remember, if you are using lithium aluminum hydride, so you must need to use in dry ether, and if you are using NaBH4, so it should be aqueous. But this is condition. They just gave us NaBH4, so we can understand that they are talking about the reduction of ketone, right?
Right.
Okay, in the third one, you can see this, they are asking for compound S. So if you focus over there, they are adding cold KMNO4. Cold KMNO4 is actually the chemical properties of alkenes, if you remember that. Alkenes can, that if you reacted with cold dilute KMNO4, so we know that what happened, it is actually going to break the double bond, and on both the carbons we have OH is going to be attached. So this is a chemical property of alkene, not ketone. So we are not going to change ketone over here. We just need to draw the same structure, and without any change in ketone, we don't need to disturb ketone over here. We just need to change alkene over here. So the double bond is going to be break. So this carbon and this carbon is going to be have OH functional group. Yes, is that right, bacho?
Yes, sir.
Yes, sir.
जिन दो कार्बन के दरमियान डबल बॉन्ड था, उन्हीं दो कार्बन पे आपने OH लगाना है. दैट्स इट. ओके. राइट सो अभी मैं कंपाउंड टी आपको इसलिए नहीं बता रहा हूँ क्योंकि कंपाउंड टी जो है आपके पास इज एक्चुअली नॉट द पार्ट ऑफ आवर सिलेबस राइट नाउ, क्योंकि अभी तक हमने इसको किया नहीं है. व्हेन वी विल डू दिस देन डेफिनेटली हम ये पार्ट भी उसका करेंगे. दिस इज आइडोफॉर्म रिएक्शन. तो अभी इस चैप्टर में हमने इसको नहीं किया, हम इसको बाद में करेंगे. सो आई एम जस्ट स्टॉप here. You can see one of the part of this question, how need to solve this. So we know that cyanide is negative over here now. So we need to see that it has a lone pair as well. So ये lone pair बनाने का आपको mark मिलेगा. ठीक है, पहली बात. Then we know that carbon is partial positive and oxygen is partial negative. So आपको इसको mark मिलेगा. Then we need to attack on this and it should be curly arrow, and this should be attacked like this and it should be curly arrow. तो इसका आपको mark मिलेगा. जब ये कर लिया आपने, so you need to attach cyanide over there. आपने इसका cyanide attach कर दिया. CH3 is there. CH3 is there, right? And this bond is going to be break, right? और ये हो जाएगा oxygen extra electron की वजह से negative, ठीक है ना? And this is going to attack on what? Hydrogen positive of HCN, ठीक है ना? आप उसको इसमें attack करता हुआ दिखा सकते हैं. And in the last step, you are going to see that कि यहाँ पर आपने cyanide लगा दिया, यहाँ CH3, यहाँ CH3, and then this should be OH, right? So it will give you 4 marks for this mechanism, and we know that this is nucleophilic addition reaction, so you can write the name of this mechanism as nucleophilic addition reaction. So this is a 5-mark question, so you need to solve like this to get all 5 marks. Is that clear, every one of you?
सर
जी बेटे.
सर इन पार्ट 2 हम लोग H पॉजिटिव लिखेंगे या फिर हम लोग HCN बनाएंगे?
आप HCN बना लें, कोई मसला नहीं है. आप HCN बना लें. HCN में भी तो आप अटैक हाइड्रोजन पे ही होता हुआ दिखाएंगे ना. If you are drawing this like आप HCN यूं करके बनाते हैं तो CN is partial negative और हाइड्रोजन is partial positive. So ठीक है, कोई मसला नहीं है. मैंने सिर्फ हाइड्रोजन लिखा है तो ये हाइड्रोजन वाटर से भी हो सकता है, तो इसलिए मैंने पॉजिटिव लिख दिया था उसको. अगर आप सिर्फ हाइड्रोजन भी लिखेंगे तो दैट्स फाइन, क्योंकि ऑक्सीजन अटैक तो हाइड्रोजन पे ही कर रहा है ना. ठीक है,
ओके सर.
right? Okay, so let's see some other questions as well of this topic, and we have one more question over here. If we talk about this question, but how can we solve this? It is again a very good question. We can solve this to view our learnings, that how much we learn and how much is remain. So let's see. They are asking for reaction 1 and reaction 2 can both be carried out using the same reagent. Identify the suitable reagent for reaction 1 and reaction 2. Sure, we can see this. Just look at over here. This is what? This is alcohol because it has hydroxyl functional group. And reaction 1 is showing that alcohol is converting into carboxylic acid. And we know that this is oxidation. So when we talk about oxidation, so we should use acidified potassium magnate or acidified potassium dichromate, right? If you talk about reaction number 2, so if you talk about reaction number 2, so this is actually carboxylic acid, and now alcohol is actually changing into aldehyde, right? So again, the same thing, oxidation. And for the oxidation, we should use what? Acidified potassium dichromate, right? Because it is what? It is aldehyde. Agar ye ketone hota, so you can say that we can use acidified potassium magnate, directly convert hota. Lekin aldehyde mein jaane ke you should use at least you can say a little weaker oxidizing agent as compared to potassium magnate. Potassium magnate is a very strong oxidizing agent, right? So they are asking for the suitable reagent for the reaction 1 and reaction 2. So we can say that it is actually acidified potassium magnate. And if you are writing the name acidified potassium magnate, you need to keep remember that you need to write the oxidation state of manganese over there, which is 7. It's very important. It is acidified potassium magnate 7, right? And they are saying state and explain how the reaction should be carried out to ensure that reaction 2 rather than reaction 1 occur. If you want that the reaction 1 occur, so the condition which is very much important is we know that we should heat under reflux, right? So you can say that heat under reflux, right? Heat under reflux is important. So heat under reflux. So the reaction has been completed. So the reaction has been completed to give carboxylic acid. Right, बच्चों?
Sir, but
और
they're
अगर
asking
carbox-
about reaction 2.
state and explain how the reaction should be carried out to ensure that reaction 2 rather than right. If you want to say that कि अगर आपके पास aldehyde बने, so what you need to do, we don't need to heat under reflux. What we need to do, we need to do heat and distill the product, right? We need to do what? Heat and distill the product. So we can do heat and distill the product. Sorry, my bad.
सर एक सवाल
So this, जी बेटे पूछें.
सर हम
ठीक
लोग
है.
जो ए के अपार्टमेंट के अंदर हम लोग ये लिख सकते हैं एसिडिफाइड पोटेशियम डाइक्रोमेट एज ए रिएक्टेंट.
या बिल्कुल लिख सकते हैं आप, दोनों में से कोई सा भी लिख सकते हैं. And I just recommend you to write acidified potassium dichromate, which is more important, right? Because I told you that अगर आपके पास potassium dichromate होगा तो वो weaker, आपके पास potassium magnate से थोड़ा सा weaker है और वो जो है अच्छा काम कर सकता है aldehyde के लिए, क्योंकि potassium magnate में chances होते हैं कि वो reaction पूरा करा देगा क्योंकि strong oxidizing agent है, ठीक है ना? तो अगर आप potassium dichromate लिखते हैं तो it would be more good. अदरवाइज ये भी चलेगा, क्योंकि मैं ये वाला इसलिए लिख पाता हूँ क्योंकि ये आपके पास ओ लेवल से कनेक्टेड है, आप लोगों को शायद ये याद रह जाता है, तो इस वजह से मैं ये लिख पाता हूँ. अदरवाइज आपको अगर आप याद रख सकते हैं तो कोशिश करें कि आप पोटेशियम डाइक्रोमेट ही यूज करें, ठीक है?
यस
और
सर.
करते हैं और करके लिख सकते हैं हम पोटेशियम डाइक्रोमेट, पोटेशियम dichromate. And if you want to write the formula over there, so it should be KMNO4 and it is K2Cr2O7, right, bacho? Heat and distill of the product. You need to remember this. If you want to stop the reaction at aldehyde, so you need to heat and then you need to distill of the product. And if you are going towards the complete reactions, you need to do heat and reflux, right, bacho?
सर
जी.
सर इसके ऊपर 2 मार्क्स मिल जाएंगे हीट एंड डिस्टिल.
हीट एक नंबर मिलेगा आपको एंड डिस्टिल ऑफ का दूसरा नंबर मिलेगा आपको, ठीक है? बट मैंने यहाँ पर आपको सिर्फ डायरेक्ट आंसर ये लिख के दिखा दिया, की पॉइंट लिख के दिखा दिया, आपको उसको पूरा एक्सप्लेन करना है, ठीक है ना? वो लिखा हुआ देखें, स्टेट एंड एक्सप्लेन. यू नीड टू एक्सप्लेन दैट वी नीड टू हीट एंड डिस्टिल ऑफ द प्रोडक्ट. जैसे ही वो बनेगी आपने उसको डिस्टिल ऑफ करना है. इफ यू आर कंटिन्यूअसली हीटिंग दैट एंड यू आर नॉट डिस्टिलिंग इट ऑफ, सो इट विल बी गोइंग टू फॉर्म कार्बोक्सिलिक एसिड. सो you need to write over there, otherwise it will oxidize further to form carboxylic acid, right? You need to write over there, otherwise it will or it would oxidize further to form propanoic acid. This is 3-carbon carboxylic acid, so you can say that it is going to form propanoic acid, right? Okay, then identify the necessary reagents and condition for each of the reaction 3 and 4. Reaction number 3. Yes, alcohol से आप गए हैं किसमें बच्चों? Alkenes में. So what should be the reagent and condition? Quickly.
H2SO4.
Yes, but you need to write over there concentrated H2SO4, right? It should be concentrated H2.
Al2O3.
Yes, you can say that. Alternative के तौर पे आप Al2O3 भी use कर सकते हैं, but it is reagent. What about the condition?
Heat.
350 degrees.
Yes, for sulfuric acid it is 200 degrees centigrade, and for ammonium oxide it should be 350, right? So any one of them you can use. And then reaction number 4, it is alcohol, and now we are moving towards alcohol to halogenoalkanes into bromine. You need to keep remember that कि halogenoalkane में chlorine वाला भी होता है, bromine वाला भी होता है, iodine वाला भी होता है. तो अगर हम alcohol से bromine की तरफ जा रहे हैं तो हमें क्या use करना चाहिए बच्चों? We need to NABR. We need to use red
phosphorus and HBr.
Bromine gas. Whenever you are going to use red phosphorus, you need to use bromine along with this. Or if you are going to use HBr, so you need to use HBr gas, or you can even use concentrated HBr, right? And for this, you need to heat, right? Right, बच्चों? Red phosphorus के साथ bromine use होगा, ठीक है? चले नेक्स्ट देखते हैं. नेक्स्ट आपके पास ये एक और बार आ गया है क्वेश्चन, सो जरा जल्दी से इसको ट्राई करें आप लोग सॉल्व करने की. क्या आप लोग इसको सॉल्व कर सकते हैं? देन और एक बार दोबारा देखते हैं कि हम यहाँ पर दोबारा से मार्क्स कैसे ले सकते हैं. You can see this again, there are 4 marks, right? So you need to keep remember, first of all, you need to show a lone pair on carbon, right? So over here, just look at this question. And in this question, you need to show a lone pair on carbon. And along with this, you need to show that it will attack on carbon. So in दोनों चीजों का आपको 1 mark मिलेगा because it is connected with nitrile, right? And then for the second mark, you need to keep remember that जो carbon है आपके पास, it should be partial positive and this should be partial negative and this bond breaks. इसका आपको 1 mark मिलेगा, ठीक है? And then you need to keep remember
Sir?
when you are form. जी.
Sir, we will make it attack from the back also, no?
You can attack from anywhere because this is a planar, right? Carbonyl carbons are planar molecules, so you can attack from anywhere. This is no issue, right? The issue is with only that when we were talking about electrophilic addition reaction and when we were talking about nucleophilic substitution. So it will always hydroxide attack from the opposite side on the bromine or on the chlorine, right? So over here there is no issue because this is planar molecule, so it can attack from upward or it can attack from downward. No issue for that, right?
Right, sir.
Then in the middle, you need to show that the intermediate over there. So intermediate would be like this, that this is hydrogen, this is oxygen, and you must need to show the lone pair over there and the charge over there. It would give you 1 mark for this, right? And over here we have CH2, CH3, and in the bottom we have cyanide, and you need to show that it is attacking on hydrogen ion, right? This oxygen is attacking on hydrogen ion, and this will give you 4 marks over here, right, every one of you? So keep remember the 1 mark for this lone pair and this attack, second mark for these partial charges and this attack, third mark for this lone pair and the overall intermediate charge, and the 4th mark for this attack, right? So you will have these 4 marks in this question, and then they are asking for what? Stereoisomerism. We know that the central carbon over here, it is actually having 4 different types of species bonded with a single carbon. So it is actually chiral center. So whenever you talk about chiral center, so it can show optical isomers, right? So first of all, you need to draw it in the 3-dimensional state. So it will be like this: CH2, CH3, and then you can draw it like over there hydrogen, and this is nitrile, right? And this is what? Hydroxide. So this is one of the molecule, and you need to keep remember, we need to talk about the mirror image of this structure. So it will be what? It will be optical isomers of this. So what you need to do, you just need to replace nitrile and CH2, CH3. So it will be nitrile over here and CH2, CH3 over here, and the rest of the molecule is same. So if you want to draw edge in this way, or you can even change it as little like this, because this is a mirror image, so it will be like this, right, bacho? Right, bacho?
Yes,
Right,
sir.
sir.
Now they are asking for suggest
Sir.
why a mix. जी.
सर हम लोग जो OH और H को अप एंड डाउन कर सकते हैं?
Yes, you can do anything, right? You can do anything over here. कोई से भी 2 चेंज करने, बट आपने बस ये याद रखिएगा. Then if you talk about the third one, they're asking suggest a mixture of 2 stereoisomers is formed by reaction 5, and I told you that this is actually aldehyde and this is actually ketone. Whenever you talk about aldehydes and ketone, they are planar molecules. So this nitrile can attack from anywhere. It can attack from the upper side, or it can attack from below as well. So whenever it can attack anywhere, so it can form 2 different isomers or 2 different structures as well, right? Or you can even use over here that there is a chiral carbon, so it can form optical isomers as well. Anything that you want to write over here. So you can say that there is attack, the attack can be possible from upward or downward. So that is why you will see that the 2 different isomers will be formed, right? Or you need to use the word as well that this molecule is actually planar, right? So nitrile can attack from upward or it can attack from downward. That is where 2 different stereoisomers or optical isomers would be formed. Or again, I told you that you can even use the chiral carbon over here. You can say that the carbon is chiral over here, so it can form optical isomers, right? Right, bacho?
Yes, sir.
So over here, this is the question. So kindly please tell me